Hi kids, now we'll be going with this phasor diagram of series RLC. There won't be anything new what you'll be seeing here. It's just for people like who are finding difficulty with drawing the phasor diagram, as some people asked me to make it. I am making it. So anyway, so let us say resistance is 3 ohm and inductive reactance is 8 ohm and capacitive reactance is 4 ohm for easy calculation, and the source voltage is 100 sin omega t sinusoidally varying. So now to find current as a function of time, we can go with mathematics, or like we kind of understood phasor also will help us in getting back the current as a function of time. So I will take current as reference. These three are in series, so current is a common thing. I am taking current as reference and I am drawing the phasor diagram. So current, I will be drawing the phasor diagram for the maximum values. Current maximum value, I am calling it as I naught. So current in the resistor and voltage in the resistor will be in phase. Current in the resistor and voltage in the resistor will be in phase. Voltage in the resistor will be current into resistance, I into R. Now current in the inductor and voltage in the inductor will be having 90 degrees, and voltage in the inductor will be leading. Voltage in the inductor will be leading the current in the inductor by 90 degrees. Now voltage in the inductor is I into XL. Now similarly, current in the capacitor and voltage in the capacitor, they will be making 90 degrees. Voltage in the capacitor will be lagging the current in the capacitor by 90 degrees. Voltage in the capacitor is I into XC, which is 4 ohm. Now the common thing among all this is the current. So I will be clubbing these three figures such that current remains same. So when I club these three figures into single figure, I will be getting this one. Taking current as reference, when I club those three, you can see here. I am taking this and I am clubbing. So this thing is here, this thing is here, and this thing is here. Then I am taking this figure. These two are in the opposite directions. I naught into 8, I naught into 4. Resultant will be I naught into 4 in the upward direction. So I am taking the vector resultant of those 3 I naught and 4 I naught. Then the resultant will be 3 I naught, 4 I naught at an perpendicular. So resultant will be 5 I naught, and which is making angle 53 degrees with this thing. That is 53 degrees with the current phasor thing. Right. Now resultant of all these voltages is giving us the source voltage. So 5 I naught is equals to 100 maximum. I am drawing the phasor for maximum value, so I will be equating it to the maximum voltage available. Now I into Z, the resultant will be of the form I into Z. So this is going to be Z, and this is going to be that cos phi power factor thing, right? Anyway, all those things you can manage. Maximum value of current will be 20. So that's how you are going to approach it. You will be drawing the phasor diagram, and you will be clubbing all the three figures, and you will be making one phasor diagram, and you will be finding the resultant voltage and equate it to the source voltage. Now you got I naught, but this is the resultant voltage. Resultant voltage is making an angle 53 degrees with the current. So current is lagging the voltage by 53 degrees. Now I am drawing the same thing. I have drawn the figure. Now while writing the loop equation, we will be assuming like this is higher potential, lower, higher, lower, higher, lower. That's how we got the result. So I am just putting it so that you understand what does it mean by negative sign. Now I naught, I got 20. So I naught into 3 will be 60. I naught into 4 will be 80. This will be 160. So maximum voltage across the capacitor is 80. Across the resistor is 60. Across the inductor is 160. Now the resultant of these three vector form will give me 100. Now if I want to write current as a function of time, see, this is the resultant voltage. Resultant voltage was given as 100 sin omega t. With respect to resultant voltage, current is lagging by 53 degrees. Voltage in the resistor is lagging by 53 degrees. Voltage in the inductor is leading by 37 degrees. Voltage in the capacitor is lagging by 90 plus 53 degrees. So let me go step by step. This is given. Voltage as a function of time given. So I need to find current as a function of time, that is maximum into, now lagging by 53 degrees. It is lagging this guy by 53 degrees. So omega t minus 53. Now similarly, voltage across the resistor, maximum value is 60. It is lagging by 53 degrees. Voltage across the inductor, maximum value is 160. It is leading by 37 degrees. Voltage across the capacitor is 80. It is lagging by 90 plus 53. Right. So I was just showing you what will happen when omega t is 2 pi. When omega t is 2 pi, this one will be 0, this one will be minus 16, minus 48, minus plus 96, minus 48. What does it mean by minus 48? While writing the loop equation, we have taken we have taken higher potential here, lower potential here, but we are getting the opposite thing. So basically this will be lower potential, this will be higher potential. Now similarly you can understand the remaining also. Current also we are getting negative. We assumed current is that way, but we are getting the opposite direction. And right at that moment source voltage is 0. Right? Now summation of these three should turn out to be 0. That must make sense. KVL is valid at any moment we take, right? But addition of these three has nothing to do with instantaneous values. This will give us 220 plus 80, 300. It has no specific importance for us. Anyway, I will be going to the next part. I will be going with the power delivered by the source. Power delivered by the source is E into I. That's the instantaneous power delivered by the source at any time. Now, power utilized by resistor will be V across the resistor into I in the resistor. Similarly, inductor, similarly capacitor. Now, instantaneous values are of no significance for us, so we will find the average values. I found power delivered by the source average value. I expanded it, then sin square average is half, sin 2 theta average is 0, and sin 2 omega t average is 0. Now similarly power across the resistor average value, it turned out to be 600. This one average value turned out to be 600, that one average value turned out to be 600. Power across the inductor average value turned out to be 0. Power across the capacitor average value turned out to be 0. So essentially average power delivered by this one is utilized by this. That by numericals you may not understand, but once you do it without numericals by taking variables E, I, you will understand. These two will turn out to be IRMS square into R form. IRMS square in this question is this much, maximum value is 20. So RMS is 20 by root 2 whole square into resistance is 3. So power effect on average power will be utilized only by the resistor. Power utilized by inductor or capacitor on average will be 0. If you need the explanation, you can refer to this part of the NCERT. I am attaching the PDF, so you can read from here also. So for some for part of a cycle it will be getting charged, for part of a cycle it will be getting discharged kind of. So for part of a cycle energy will be stored, for part of a cycle energy will be sent back. So effectively it won't be using power, right?